Okay, for today's topic, we are going to see Guttermann reaction. And as you know, from the previous video, we have seen Sandmeyer reaction. Today, there is Guttermann reaction, and tomorrow we will see another name reaction in continuation to our name reaction series. So, today's is Guttermann reaction. So, what is Guttermann reaction? It is similar to Sandmeyer reaction, in which diazonium salt is used to form a alkyl halide or aryl halide. So let's see what happens. So we have our diazonium salt as always, and Guttermann reaction can be said that it is a modification of Sandmeyer reaction, because the reaction mechanism, although different, but it is similar by using similar chemicals, but instead of CuCl there we use copper powder here. So when it goes forward with in presence of HCl, there is formation of chlorobenzene, nitrogen gas, and copper powder as it is. So this is the general reaction on what happens in a Guttermann's reaction. So let's see the mechanism now on what happens actually. So starting with our diazonium salt. So let's come down here and draw our diazonium salt. This is our diazonium salt. So what happens is, in the first step, there is cleavage between the bond of nitrogen and benzene. So this bond will be broken and there will be leaving of nitrogen gas. How it will happen? So the copper here, Cu, what it does is it has one electron which is donated to the nitrogen. So this has the positive charge, this has the negative charge. There is one electron which is going to be donated to the nitrogen group. When the nitrogen group receive this electron from copper, what happens is there is a free radical formation on the benzene ring. So benzene ring, there is a free radical formation. After this, well, here the nitrogen accepts the electron and goes away. So N2 gas is released. The copper, however, has a positive charge now, as it has donated an electron. The second step is of the HCl that is present here. What happens is, and draw it now side. So HCl breaks the bond between hydrogen and chlorine. So this is the chlorine, that is, it breaks the bond. That's the partial thing. And what happens to the chlorine is, chlorine having a negative charge, it donates one of its electron. So let's draw electron like this. So electron is formed from the chlorine group of HCl that has been broken. What will happen is because this is a radical now, electron has been removed, this is a radical, this radical will be getting added with the benzene. There is a free radical on benzene, there is a radical formed of chlorine, so it binds here, so this will be Cl. After this, the electron which has been removed from the chlorine, like chlorine has donated one electron, so this electron combines with the copper ion which has been formed during this reaction. This copper ion gets the electron given by the chlorine, so copper goes to its original state. Hence, there is formation of chlorobenzene and copper which has accepted the electron. So this was the general mechanism on how it works. The radical formed in between, the free radical formed of benzene and the radical gotten of chlorine forms the chlorobenzene. With the formation of radical, there is release of an electron. This electron gets combined with the copper, and the copper gains its original state as it is. So it acts as a catalyst. It doesn't enter the reaction and doesn't produce a different product. For its stability, it gains the electron and it is stable now. So this was Guttermann's reaction.